So we've got a question here. We want to find the radius of convergence of this power series here. So it's summed up from n equals 0 to infinity, and we've got minus 2 to the n times x to the n divided by 3n factorial. Now this is a typical power series because it's in the format of our nth coefficient here, a subscript n, times x minus c to the power of n. Now here we've just got x to the n. So in this case here our c equals 0, hence we've just got x to the n. Now first things before we can start is to try and find this nth coefficient out of this series here. Now what we do is if we just ignore this x to the n, everything else without an x term in it will be our nth coefficient. So that would lead us to our an being minus 2 to the n divided by 3n factorial. So let's write that in there first. So minus 2 to the n over 3n factorial. Now to find the radius of convergence for this series here with this kind of format, the best method we can use here is the ratio test. So the ratio test, I'll just write that up here for us, ratio test. This will give us a variable r, capital letter R, and that's calculated by taking the limit from n to infinity. So the limit as n go to infinity, and the absolute value, let's write that there, absolute value of the n plus 1th coefficient. So we write that as a n plus 1, close the absolute values, and because it's a ratio we divide that by the nth coefficient. So that becomes a subscript n. And that will give us our variable r. Now r will not be our radius of convergence, but what it will do is it will lead us to our answer. It will give us something we can work with to give us our answer. So we've got our nth coefficient. So now we need our n plus 1th coefficient. So let's write that underneath. So a n plus 1. So wherever we see an n in here, we put n plus 1. So we've got minus 2 to the n. So that just becomes minus 2 to the n plus 1. And then we've got 3n factorial. So that becomes 3 times n plus 1 n factorial. Okay. Now to make this easier to work with, I'm just going to break down this alternating series into something that we're more familiar with. So I could rewrite this here as 2 to the n times minus 1 to the n. That will give us the same value in our numerator. And our denominator, I will just leave that as 3n factorial. Now I'm going to do the same with this one here as well. So I'm going to rewrite this one as well in the same format with the n plus 1. So I've got 2 to the n plus 1 times minus 1 to the n plus 1. And that also will give us the same as this one here. And my denominator, I'll leave that as it is. Okay, now with this n plus 1th coefficient, there is still more I can do to simplify this term off here. So I'll do that when I plug it into my ratio test. So let's go for that over here. So r equals the limit as n approaches infinity, absolute value. So my n plus 1th coefficient. So let's set up our fraction. Now this 2 to the n plus 1, I'm going to rewrite that as 2 times 2 to the n. So that's going to be the same for that. And this one, I'm going to write it as minus 1 to the n and multiply by minus 1 to get our extra 1. And then divide that by this one here. As it says a n plus 1 in our numerator, with the denominator, I can still write this in my denominator here. So I've got 3 times n plus 1 n factorial. Okay, so my an, as this goes in my denominator, I will then take the reciprocal of this and plug it into my ratio test calculations. So my 3n factorial will go in the numerator. So I'll write that like this. And then this numerator term I'll put in my denominator. So I've got 2 to the n minus 1 to the n. And that's all absolute value. Okay, now we can do some simplification on this before we write the next line. So let's just get that set up. Okay, so keep the absolute value. Right, 2 to the n. 2 to the n, so they can cancel. Minus 1 to the n, minus 1 to the n, again more cancellations. N factorial, good to go. And a 3 and a 3, great, good to go. Cancel those. Now anything else I can cancel, I've got 2 and a minus 1, and I've got an n plus 1. So that's all we're left with. So let's just do the multiplication on that. 2 times minus 1, so that's minus 2. And here I've just got n plus 1. And that is all I've got left. Okay, now if I take the absolute value of this, the minus sign will disappear. So then I've got limit as n approaches infinity of 2 over n plus 1. Now as n approaches infinity, this will approach 0. So therefore my limit as n approaches infinity is just 0. So that gives me my r. Now my radius of convergence is the reciprocal of r. So if I write this here as ROC, radius of convergence, this is 1 over r, which in this case is 1 over 0. Well, 1 over 0 we know is infinity. So in which case the radius of convergence is infinity. So basically this power series here converges everywhere. So that's the result here of our radius of convergence. The radius of convergence is the maximum radius disk that the power series converges, in which case it's the whole values, basically the whole domain of this power series. So that would be my answer. So I put my radius of convergence is infinity. Okay.